Right, so 8.7 now is Parabola's standard form. So when you're dealing with standard form, that looks different than the vertex form, which is in 8.6. So standard form looks like this. It looks like y equals a x squared plus bx plus c. All right, so this a, b, and c is what's kind of changing our parabola this time, rather than the a, h, and k. And so it's just a different form on this. And maybe before I go on here, I just want to talk, because I think this might help out a little bit, is understanding the different forms parabolas. Right, there are these quadratics, I should say, but they make parabolas, right? Parabola is the shape that they make of a graph. So one type, right, if we have, so we talked about the vertex form on the last one. So when you have something in vertex form, which is that y equals a times x minus h squared plus k, then the vertex is easy to find. Right? So I'll just put vertex, right, is h comma k. So vertex is easiest to find when it's in this form.
Okay.
Okay, if it's in standard form, which is the one that we're dealing with here, so y equals ax squared plus bx plus c, right? Then the y-intercept is easy to find. So our y-intercept is going to be dealing with that c value there. 0 comma c, right, whatever that c value is, that's giving me what my y-intercept is. So again, right, the y-intercept is easy to find. Okay. And then there's one other form that you kind of talked about back when we did factoring, and it's called intercept form. And sometimes we called it factored form. So if we took something that was kind of this form, and then we factored it, and then we set it equal to 0 and solved it. Do you remember doing that? So if we had something like this, so intercept form looks like something like equals, we'll say x minus d times x minus e. I'm just trying to use different variables than we've used up here because it doesn't mean any of those. And so that d and e are our x-intercepts. So in this form, it's easiest to find x-intercepts. So with this one, right, we'd have intercepts would be d comma 0, and the other one would be e comma 0. And so in this form, the x-intercepts are easiest to find. Now you can find all of those things in the different forms, but it's just, you know, like we can't look at the standard form and just pick out what the vertex is. The vertex is a really important part of that parabola because it's the turnaround point of the parabola. right? So if we have a parabola going like this, right, it starts going down, 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 down till it hits that vertex, and then it goes back up, right? It changes direction at that vertex. And the same thing is, you know, if it was an upside down parabola, right? Our vertex is that turnaround point. Okay, and so vertex is a really important part of our parabola. But so let's going back to this over here. We need to know how to find the vertex because, like I said, it is a super important part. But really, when I'm looking at this, the only thing that I can really tell is what the y-intercept is. And the y-intercept is, you know, something good to know, but maybe not as important to know as the y-intercept. So that's why we want to look at this. So when something is in standard form and it wants you to find the vertex, you have to use vertex formula.
I need to use the vertex formula when what?
When it's in standard form.
Oh, okay.
So to find our vertex, we have to use this vertex formula. Okay. And so our vertex, to find our x value of our vertex, it's going to be, we're going to put in points that we kind of have up here. It's negative b over 2a. So that b that's written here, right, is the b I'm talking about in this formula. And then the a, that number in front of the x squared, is the number I'm going to be putting down here to put inside this formula. So that should look kind of familiar to you because when you did the quadratic formula, that negative b, you know, like remember how you have x equals negative b plus or minus square root of b squared minus 4ac over 2a. So that negative b over 2a is part of that formula. And this is the part that's telling us the x coordinate for the vertex. And then to find the y coordinate for the vertex, you're just going to plug the x value that you find into the equation they give you. Okay, so they'll give you some kind of equation that looks like this, where you know what a, b, and c are. Those are going to be numbers. And then and then we'll use this formula to help us get there. Okay, so this is definitely something you need to make sure that you get memorized for the exam.
The vertex formula?
Because that's not going to be given to you, but it's going to definitely, they're going to ask you on the next test to take something that's in standard form and find the vertex of it, you know, of that parabola. Okay, so let's do an example where we are going to do just that. Okay, so on this first one, it's going to ask us to find different things on it. So it wants us to ultimately graph an equation that's given. So say that they give us y equals negative 2x squared minus 4x minus 6. Okay, so that is our graph that's given, or our equation that's given to us. And then in order to graph it, it will ask us to find different things on it. So the first thing it's going to ask us to do is find the vertex. Okay, so that means we're going to have to use this vertex formula to do that. And so to find our x value of our vertex, we'll do negative b over 2a. So here when I'm looking at this, right, I know that my a is negative 2, my b is negative 4, and my c is negative 6. Right? And so I'm going to use this formula. So what am I going to get here? So negative b over 2a. Well, the opposite of negative 4 is positive 4 over 2 times my a, so 2 times a, which is negative 2. And then I just need to simplify this. So 4 over, yeah.
You say the opposite of negative 4.
Mm-hmm.
But just the opposite because the formula already have one negative, right? And negative multiplied by negative 4 is positive. Or doesn't matter if for example, if I have a 4, is my b is gonna be negative 4 in the vertex form.
Yep, so opposite means just change the sign in front of it.
When I have negative in this case. It's not like the same you showed me in the last section.
So this negative b means find the opposite of b. So yeah, okay. I mean, you could think of it in a couple of different ways. You could say, you could write it down if it's easier for you to say, okay, that negative, right? And then negative 4, because that's what our b was. So the opposite of negative 4 is positive 4.
Okay.
Does that help some? So you'll always be just changing the sign. That's all you have to do with that b value.
Okay, perfect.
Yep. So if it started off as, plus 4x, then we'd write it down as negative 4. But since it started off as a negative 4, we'll write it down as a positive. Okay. Yeah, and then on the bottom, so 2 times negative 2 is negative 4, and then 4 divided by negative 4 is negative 1. Okay, so again, remember I'm trying to write my vertex here. Let's see, I'll just do it in a different color just so it will stay out a little bit here. So my x value is negative 1. Now how am I going to figure out what my y value is of that vertex?
Replace?
Yeah, so we're going to go back to this equation that's given here, all right? And I'm going to put things in here that I know. So I'm going to do negative 2, and then, yep, and then we're going to put parenthesis negative 1 squared minus 4 times negative 1 minus 6, and then we just need to simplify that. So negative 1 all squared just is 1, all right, and 1 times negative 2 is still just negative 2. Negative 4 times 1 is positive 4, minus 6. So negative 2 plus 4 is positive 2, minus 6 is going to give us negative 4. So when x is negative 1, y is negative 4. So that is my vertex. All right, and remember that's like the turnaround point of my parabola. So it's like that point there. Okay, now it's going to ask us to find other things other than that just to help us. So another thing it will ask us to find is the y-intercept. And the y-intercept, to find the y-intercept, it's like you want to let x equal 0 and figure out what y is. So say if x equals 0, what is y? That's what we're trying to figure out when it's asking us to find the y-intercept on anything. It doesn't matter if it's a parabola or whatever. So I'll show you, like if I put 0 in place of my x's here, right? So go back to this original equation they gave us. So I've got negative 2 in place of x. I'm going to put 0. All right, negative 4 times 0, and then negative 6. Well, what happens to these, right? Well, we got 0 squared is 0. 0 times anything is just 0, right? So do you see that that just goes to 0? And then negative 4 times 0 is 0. And so all we're left with is whatever that C value is. So remember I said up here to find that y-intercept, right? It's always going to be 0 comma C, and that's what our C is this. So we don't have to go through all of these steps. I'm just trying to show you like why it is that way. But our answer for this is going to be, so our y-intercept is going to be 0 comma what?
-6.
Yeah. Right? So when x is 0, y is -6. And that's what we found here. All right, because those zeros don't really
And that
matter.
one is my y-intercept.
Y-intercept, yep. Okay, and then the other thing that they might ask you to do is to find the x-intercepts on it as well. And so with the x-intercepts, you want to see if you can factor it. And if you can't factor it, then you'd have to use the quadratic formula that you talked about earlier on in this chapter. All right, so the next thing it's going to ask you to do is find x-intercepts. Okay, and again, just like, so with y-intercepts, right, we said if x equals 0, what is y? To find x-intercepts, we're saying if y equals 0, what is x? So this time we're going to put 0 in place of our y. So I'll have 0 equals negative 2x squared minus 4x minus 6. And then if I look to try and factor this, this actually isn't going to factor. And so I'll end up having to use the quadratic formula on it. What is going on here? Don't know what's happening. All right, so let's go ahead and put it into that quadratic formula, right, which is, so x equals negative b, right, or the opposite of b, so it's going to be positive 4 plus or minus square root of b squared, so negative 4 squared, minus 4 times a, which is negative 2, times c, which is negative 6, all over 2 times negative 2. And then we just need to simplify things up in here. Okay. But so let's focus on inside the square root here. So I've got negative 4 squared is positive 16. And then a negative times a negative times a negative is going to be negative. All right. And so I have 4 times 2 is 8. 8 times 6 is 48. But then do you see here, like, so I've got 4 plus or minus the square root of what? What's 16 minus 48?
Is minus 32.
Yeah. And can I take...
in that case, imaginary number?
Yeah. So that's going to be an imaginary number. So that means there are no x-intercepts. Okay, so no x-intercepts. And I'll talk about that a little bit more when we graph it. Okay, so that's not really helpful for us, is because there's no x-intercept. So right now all I have is the vertex and I have the y-intercept. Okay, but there's one other thing that can help us when we're graphing this, and it's called the line of symmetry. So parabolas are symmetric. So let me go back up here to like my little pictures that I drew. All right, so do you see like, I mean, I know my pictures aren't perfect, but imagine that they are. If I had a dotted line that went straight up and down here through the vertex, and I like folded it on that dotted line, then one side of the parabola would, yeah, would match up with exactly the other side of the parabola, right? And same thing would happen with an upside down parabola, all right, if it's going through that vertex there. So that line of symmetry is helpful for us. And so whenever we're dealing with these, well, these are, you know, like vertical lines on here, right? Straight up and down lines. And back in the first module, we talked about how those lines that are vertical lines are always x equals some number, right? Well, that x value that you're coming up with that line, we said it's going through the vertex. And this is our x value of our vertex, and so that means our line of symmetry is going to be x equals -1. Okay, so whatever our x value is of our vertex, we'll write that as an equation of a line by saying x equals 1. So this is, let's kind of put to the side here, this means it's a vertical line at -1. Okay, so then the last thing that we have to do here is graph it. Okay, so let's try and use what we know here to graph some of these things. Okay, so I've got my vertex. So to the left one, down 4 is right here. Okay, and then my y-intercept is over 0, down 6. So that's here. Okay, and notice that in my equation, this a value is a negative. And that's telling me that this is going to be an upside down parabola because it's negative. So when this a value here is negative, that's also telling us, just like it did on the last one, that it's going to be upside down. Okay, so we know this is going to be an upside down parabola, and so we can kind of see that part of it is going like this. Okay, but how are we going to figure out what the other side of it looks like? Well, let's keep in mind, we know this line of symmetry here. So it's a straight line, and I know my lines don't really ever look really straight on here, but it's going through here. And so there's symmetry here. So I know that I had, so this was down 6, right? That was at -6. And so if I go one more over to the right here, or to the left, so that -2, and I go down 6, that's going to make it symmetric. Do you see that? So even though I'm only given these 2 points, I can find that third one by saying, oh, well, because it's symmetric, there's got to be a point that is straight across from there in that symmetry. And so then I can kind of draw the rest of my parabola there. And so now that is done. Now, the reason why there's no, look at our, so that became an imaginary number, because look at this is never going to cross the x-axis, right? There's no x-intercepts because it's an upside down parabola that's already below the x-axis. So yeah, so there can't be any x-intercepts, right? Just like if we had a right side up parabola that was, say, above the x-axis, This isn't part of our answer, but I'm just trying to say this would also give you imaginary solutions because there's no place where they're going to cross the x-axis. Is that making sense?
And when don't cross the x-axis, what it means that?
So if I have something like this, let's see here. So let's say I have a graph like this, and I have so let's say, so this is 1, 2, and 3, right, on my x. And so say that I had a parabola that looked kind of like this. Well, the places that they're crossing the x-axis are our x-intercepts.
And what happened when don't happen that? In that case, like in the example you're giving me right now.
In this one right here?
Yes.
Yeah, so that means like if you tried to use the quadratic formula, you're going to end up with imaginary numbers because there are no x-intercepts. That's why you come up with imaginary number here, because there's no place. So say that, so this one, if we tried to do the quadratic formula or something, we'd come out with x equals 1, all right, because that's what this one is, and x equals 3. So you'd come up with two solutions where it's crossing the x-axis. But here, this is never going to cross the x-axis. This one's never going to cross the x-axis. So when you come up with imaginary solutions, when they tell you to find the x-intercepts, that just means you kind of have a what I call a hanging parabola. It never crosses the x-axis.
I have a question about the other side.
Mm-hmm.
I understand the side when it's -1 and then -4 to find the point, and then take the -6 to put the other point. But when toward this 10, how much the parabola moved to the left when I do the other side?
So it went
how skinny is.
Yeah, so do you see how it's one place over and two down? And so same thing here, one this way and then two down.
Okay.
Yep. So since it was one place over, two down, then you'll do the same way going on the other side of it. One place over, two down. If it was, one place over, three down, then you would do that. One place over, four down, right? So however many it's going over and down is the same that you'll do on the other side.
Okay.
All right, and we're going to need to stop there because I have an appointment that starts in a minute here. So maybe try some of these and then just let me know